Hi everyone. So the next speaker is Ashwini, and the title of her talk is Introduction to HTTPS, a Comedy of Errors. So please welcome her.
Hi everyone. I'm Ashwini. I write a lot of Python code. What's that? Okay. Yeah, I've worked on Twisted in the past, and Hippie, which is a PHP virtual machine written in our Python. And I've also spent some time in Stripe open source retreat trying to write a TLS 1.2 implementation in Python. Today, I'm going to talk about HTTPS. Let's start with some code. It's a simple line that tries to open a website, give it some data, in this case, a secret with a secret as a token. And there's HTTPS in the URL. So it looks secure, right? I mean, HTTPS stands for HTTP secure. But well, you'd think that sadly, this is pretty much insecure, and it's as bad as not using any encryption at all. Ready-made spoofing tools on the local network can steal the secret with a man-in-the-middle attack. The problem here is that urllib2 does not validate SSL certificates at all. Python 2.7.9, which was released a few months ago, supports TLS validation, but even then, it's not on by default. So, and there was no support for it at all before that. So, before moving on, let's talk a bit about the types of attacks that can happen on any kind of communication. There's passive attacks, where the attacker only needs to be able to listen to the communication without injecting or rerouting. For example, a crypto flaw might allow an attacker to just read your encrypted traffic and decrypt it silently. Active attacks, on the other hand, involve sending data to either party or misdirecting traffic. This usually takes the form of a man-in-the-middle attack. TLS is largely not vulnerable to passive attacks, though there's always the possibility. Before learning how that security hole I showed you can be fixed, let's learn a bit about TLS. Most of the talk, I know this is misleading because the topic says HTTPS, but most of the talk is about TLS because HTTPS is just HTTP on TLS. So a disclaimer before we move on. SSL is secure sockets layer. TLS is transport layer security. SSL is old and busted and shouldn't be used anymore. I mean, the most recent latest release of SSL, SSL 3.0, was in 1996. And TLS 1.0 was first released in 1999. And TLS 1.2, which is the most recent one now, was released in 2008. So TLS has superseded SSL. Don't say SSL. Please use TLS. Now, TLS was designed to secure TCP connections. There are two aspects of actually doing the securing. Certificates can be used for authentication. Certificates allow us to identify a peer. Without authentication, the encryption is pretty much useless. It's like picking up a phone and actually verifying who you're talking to before you give them your credit card numbers. I mean, don't do that, that's like bad, but still. So validation answers questions like, can I trust this website? Or specifically, is this website being served by the same person who owns the certificate for the website? This is a form of authentication because it's a verification of identity. So how does validation really work? We validate certificates by using public key infrastructure. So websites have certificates, which are authorized by organizations called certificate authorities, or CAs. the CA authorizes certificates with cryptographic signatures. Now, your computer has a big list of CAs that it trusts. So whenever a client receives a certificate, it goes through its database of CAs, checking if it is signed by any. After that, it can decide if it trusts the website or not. So there may still be something missing. Imagine Bob's IT person gets a certificate for bobsburgers.com. It is signed by a trusted CA, so it's totally legit. But the IT person goes to Starbucks and sets up a spoof server that redirects gmail.com to their laptop. Now, like, they use the bobsburgers.com certificate for the spoof gmail.com website, right? So your client will say, sure, that looks good because it's signed by my CA bundle. But sadly, that's like wrong. So fortunately, we have hostname checking to the rescue. Clients can check that the hostname on the certificate they receive is the same that they requested. Now, this is an important line of defense against MITM attacks. There are other things, of course, that we must check when validating a TLS certificate properly. For example, is the certificate past its expiration date? And if the certificate was compromised, it can also be revoked. So revocation, although, is a whole different talk. It's a whole different mess, and I won't speak of it now, but just saying it's there. So that was authentication and certificate validation. Next comes the actual encryption. So for the purpose of this talk, I'm going to let it be a black box. And for most normal usage in our day-to-day lives, we don't need to know what the magical math thing that encryption is. So I'm just going to move on and not like go into depth about this. Instead, I'm going to talk about TLS more. So how does it work? Let's try and walk through a TLS session negotiation to see this. So TLS is a network protocol, right? So there's a server and there's a client involved. The first and the most important thing about TLS is the handshake. So the client tries to establish a connection by sending a client hello message. And, well, a lot of stuff follows, and this is kind of a high-level look at it. The server responds with a server hello. They exchange information, keys, and other things needed to establish a secure connection. And then, like a lot of decisions are made. They need to agree upon a protocol version, encryption algorithm, hash algorithm, key exchange algorithm, cipher suites. But once all these decisions are made with some magical math and a couple of TLS messages, the switch of encryption is flipped, and yay, everything is secure. I mean, in theory at least. So next, I want to talk about two very broad classes of software. First, let's look at the ones that how TLS is implemented. So software that implements TLS. I'm just going to throw some TLS implementations at you. I'm not going to like discuss each one of them specifically, but yeah. OpenSSL written in C, like very popular. Boring SSL is, a disclaimer here. I don't think Boring SSL has a guaranteed stable interface, so it's not for anyone but Google yet, but it's Google's fork of OpenSSL. There's Secure Transport, Apple Staying, there's GNU TLS for Linux hippies. So all these implementations have a lot of flaws, both in the way that they're implemented and in the APIs that they expose. So there's an interesting commonality in like all the popular implementations of TLS, that they are all in either C or C++. They've all had bugs caused by memory and safety, and some of them were like really big. Heartbleed was a simple lack of bounce check that allowed attackers to steal and retrieve random data from the RAM. It was not a crypto flaw. It was just a classic don't write network code in C moment. So a lot of flaws are just plain logic errors too. Multiple TLS implementations had a bug accepting any certificate as valid if it was signed by a trusted non-CA certificate. I repeat, even if the certificate is not a certificate authority certificate. For example, the Bob's Burgers example, that certificate could sign a rogue certificate for gmail.com and it would be accepted. So you probably won't be able to read the code on the slide, but it is the official OpenSSL example for making client connections. I took it from the official documentation, and this is the example going to connect to a random website on port 443 and make a hard-coded GET request. And this is like not user-friendly. It's not just a crappy, verbose API, it's an unopinionated API. So that means that you have to choose your own settings. Like, remember the bazillion decisions I mentioned from the TLS Handshake earlier? Forcing application developers to make these decisions is bad. First of all, it allows them to make bad decisions. And then it prevents applications from being migrated easily to better settings as and when they become available. So this could be so much better. Now, there are not just implementation flaws. SSL and TLS have a rocky history with backwards compatibility. There have been a ton of downgrade attacks that allow attackers to prevent a secure connections from being established, which further allows them to take advantage of the less secure session that they've caused. So, even though HTTPS is just HTTP on TLS, there are a lot of interesting, unique attack vectors here. There are not just problems with the authentication or cryptography. Rather, there are the attacks based on subtle browser behavior. So for example, cookie stealing is an interesting one. So the user connects to a secure HTTP website that stores a cookie on their system. So far, so good, right? The attacker cannot attack this encrypted traffic to the target website, but they wait for you to submit an unencrypted HTTP request to any other website. Then they step in and respond with a redirect to the target domain, but on port 80. So because any site can issue a redirection to any other site, your browser happily follows, and this results in a plain text connection to the target website, which includes all the non-secure cookies in your browser's possession. Now, this can be mitigated with, by setting a secure flag on cookies. But many developers forget to do that. And this exemplifies how tricky securing HTTPS is. It's an extremely complicated combination of factors. And even when the cookies are flag secure, there's still cookie injection. It uses a similar technique. Non-encryption breaking man in the middle can redirect to the target domain on port 80, and then send a set cookie header to overwrite arbitrary cookies for that website. So your secure cookies aren't resistant to tampering either. In a lot of cases, the user can be considered a security flaw because they do insecure things, right? But for example, clicking through certificate warnings, but I don't think it's really the user's fault. We don't prevent them from connecting to websites with invalid certificates because we train them to click through warnings by having so many of them. So moving on to software that actually uses TLS. Let's look at the example that we had in the beginning. Now, even though it supported TLS, it was used incorrectly and thus causing huge security holes. So it's easy to blame urlib2 here, but I think that it is a failing of industry. If easy, opinionated, secure TLS APIs existed, we wouldn't have had this problem. And this is just like the usability problem with browsers, but for developers instead. Fortunately, there's the requests library. It will throw an error at you if the site has a bad certificate. But it is sad that URL-lib2, which I think every new Python programmer would use, is horribly insecure. Everyone in the know uses requests, but because it's secure. Well, actually, because that's like easier to use than URL-lib2, but it's also secure. Well, I'm sorry that I'm being so negative about all these flaws and attacks, but it's true, things are getting better. People are beginning to care. OpenSSL is getting more attention, so new alternatives are showing up, which means that there's hope. But things could still be better. Most of these libraries are still implemented in memory unsafe languages. Now, there's a project called PyCA's Cryptography, which is a Python project that aims to have opinionated APIs while still exposing low-level primitives when required. So this hides the complexity and at the same time exposes it to the ones who actually want to see it. There's PyCA's TLS. Oh, by the way, you can access these on GitHub. It's github.com/PyCA/cryptography. So yeah, there's PyCA's TLS, which aims to be an easy-to-use and safe TLS 1.2 implementation that I worked on for a while during the Stripe open source retreat last year. I haven't quite had the time to work on it further, but if any of you awesome people out here are interested, please contribute. I'll make sure that I make time and your contributions don't go waste. So my favorite part of the talk, what can we do? There's this tool called SSL Test on sslabs.com. You could use that. It's really good. There's, so Hinig has a page on configuring TLS. And this is not just an excellent guide, it's also well-maintained and frequently updated. So you should definitely go check it out. And you can also test your clients against servers with bad certificates to make sure that everything is fine. But so here, I was looking for a knowledge base of sorts where you could just have a list of all the servers with bad certificates, and anyone wanting to test their clients could check against it. I didn't find it, and I've been talking to Ian, who works on requests and maintains a lot of awesome libraries, but we're trying to work on making this happen. If you know of something, do let me know. There are also excellent books. I've used a lot of content and diagrams from these. Bulletproof SSL and TLS will give you a lot of context about TLS that you need to know for TLS to be right. There's The Tangled Web, which is a really good book about what's wrong with the internet and hopefully how you can make it better. There's LVH, who's giving 2 talks today. He has written a book called Crypto 101, which is an excellent introduction to cryptography for developers who don't know anything about it. So I suggest starting from there. So I know it looks scary, and I would say be brave. Don't be afraid to learn. Help us out at the Cryptography Project. We're all friendly people, so like hop onto IRC, go to this channel, and talk to us. Thank you. Any questions?
So we have a few minutes for questions. So if you've got one, please step forward.
Why is it bad to trust an expired certificate?
I'm sorry, can you repeat?
Why is it bad to trust an expired certificate? Like, why can't you trust a certificate that's expired?
Because the certificate is a proof that the site was actually owned by the person who was supposed to serve it. An expired certificate means that what if the ownership changed? Like, what if it's just not saying the same thing anymore? So, thank you for your question.
I guess not really a question, but another alternative TLS and SSL library is Liberate SSL, started by the OpenBSD guys. So that one's also really pretty good, and they're taking their own fanatical look at their code base and taking it to SSL. So that's a very good progress.
Thank you. Noted. Do we have more time or more questions? So. All right then, I guess that's that. Thank you.